In this next video for week 1, we're going to talk about sampling methods, meaning how do statisticians collect data? As statisticians, we want representative samples. And the reason we want representative samples is we want our sample data to accurately reflect the population we pulled it from, meaning we want all subgroups of a population to be represented in our sample. We want to ensure that we're minimizing bias and that we're accounting for things called lurking variables, which will come up in the text. And the way we do that is we do that with randomness. So our samples should be random. Whatever sampling method we use, we want to introduce some randomness into that selection process. The other thing we can do is we want to make sure that our samples are reasonably large. The more people in our samples, the more likely it is that they will accurately reflect the population. So in statistics, when we're talking about sample size, larger samples are generally better. There is, of course, a reasonable cap to that because the more people you have to interview or data values you have to collect, the more time and money that you have to spend getting that data, and the more time and money you're going to spend while you analyze it. So there are cost and benefit analyses that happen as a practicing statistician on how big is too big, where's that optimal sample size. And we'll talk a little bit more about that later this semester. We're going to focus on 4 types of random sampling, and then we're going to talk a little bit about sampling methods that are not random. The first type is called a simple random sample. Or SRS for short. And you'll see me use SRS for the rest of this semester because I am lazy. So a simple random sample is a sample where each member of the population has an equal chance at being selected for the sample. And there are a couple of ways to guarantee this. When you think of simple random sampling, you might think of names in a hat where you're just randomly selecting names that have been put in a hat. Every name is equally likely because their name is only in the hat once. More common, now that we live in the digital age, is using random number generators. Meaning every person in the population is assigned a number, and then you use a random number generator to select numbers from that list. The next type of sampling method is called a systematic sample. For a systematic sample, the population members are placed in a list, and then a random starting point from that list is chosen. Because I don't just want to start with the top of the list, that's going to give a bias towards people whose last name starts with A, or who have the youngest age, or have the lowest value of whatever it is that we're measuring. So we would use a random number generator to choose a random starting point in that list. And then every kth person from the list is chosen. So for example, I would put students at Shasta College in a list by student ID. I would randomly choose a starting point. Except I can't spell today. So I would use a computer to help me pick that ID number that I'm going to start with in the list. And then I'm going to choose every fifth ID. And I would keep selecting every fifth ID until I have the number of people in my sample that I need. So let's say I needed 30 people for my sample. I would choose the first ID I selected. I would count 4 down. I'd choose the fifth ID. That would be my second. I'd count another 4 down. The next fifth one would be in my sample. And I would keep going with that pattern. Skip 4, choose the fifth. Skip 4, choose the fifth. Until I had pulled 30 IDs from that list. The next 2 samples sound very similar and are often confused. Both of these samples are based on grouping. The first is called a stratified sample. And the groups that we're splitting our population into are called strata. You'll notice I use the word population is sorted. We do this. As statisticians, we're going to sort into groups based on some characteristic of interest. So, as a sociological researcher, as a psychologist, as a medical researcher, I might sort by gender, by age, by ethnicity, by income level, things that differentiate people in my population. And we do this most often when we want to ensure that all of those subgroups get included. So stratified sampling is really great at making sure that all of the subgroups show up in your sample. Once we've kind of stratified our population into groups based on whatever characteristic we're interested in, we then select a simple random sample from every strata. So, for example, I also teach high school. So I may have all of my students here at Rancho San Juan High School. But I don't want to interview all, 1,700 students. That's going to take too long. I don't want to file through all that data later. So what I'm going to do is I'm going to divide them by grade level. So freshmen, sophomores, juniors, seniors. And then I'm going to do a random sample of 20 students from every grade level. And it's important that those 20 students are selected randomly. So names in a hat, random number generator to pull student IDs from each grade level. Right? So 20 students from my freshman class, and then I do the same thing for the sophomores. And I'm not going to do this for the whole video because you get bored, but the same process. Simple random sample from each group so that I have a sample of 80 students, 20 of them from each grade level. So I would be certain that my survey results accurately represent the entire student body across all age groups and grade levels. The next sample method that depends on grouping is called a cluster sample. And there are two important differences that make a cluster sample different than a stratified sample. The first is that generally when we use cluster sampling, we're using cluster sampling because the population already exists in natural groupings called clusters. I didn't need to go subdivide them by category. They exist in natural groups. Zip code, school district, right? Things that already exist, structures that exist in nature or society that I didn't have to place them in. The other catch with this grouping is generally we want those clusters to be similar, because the next thing we're going to do is we're going to collect an SRS of clusters. Not of individuals from the clusters, but from the clusters themselves. Once I've randomly selected a handful of those clusters, everyone in those selected clusters is used for your sample. Which is different than what we did up here with stratified. Stratified, I chose 20 from every group. Here, I'm only going to choose one or two of the groups, but everyone in those groups is going to get used. So, for example, California has 50-some counties. I'm going to look. See how fast Google is. 58 counties. There we go. So California has 58 counties, right? Those counties already exist. Those are groupings of humans that I don't have to do anything to separate them as a statistician. And then I'm going to randomly select a handful of those counties. And then what makes this a cluster sample is that all of the adults in those 5 counties become part of my sample. You can see some disadvantages here right off the bat. We know that not all counties in California are equal. Some counties tend to be predominantly lower income, some tend to be predominantly upper income, some are predominantly white, wealthy and white, some are predominantly people of color, some are predominantly young, some are predominantly old, right? All of those things would be things I would need to consider as a statistician. If I'm studying something where those categorizations matter, clustering by county might not be a good choice. So as a statistician or a member of a research team, you really have to sit down and look at which of these 4 sampling methods matches best with the type of question you're trying to answer and the limitations placed on things like your budget and the tools that you have accessible to you. Okay, so on to the type of sample most commonly used by students. Non-random samples are less ideal because we know that they're not going to produce representative samples. They don't account for things like lurking variables. The most common type is a convenience sample. Please don't judge my spelling. Convenient sampling is what it sounds like. The researchers selecting people based on convenience. or ease of access. For example, when I took statistics way back in the 90s at my local community college, we had to do a final project where we actually had to go and do statistical analysis on data we collected. So I interviewed students at 2 local high schools. And to do that, I went to the courtyard at lunch and just interviewed kids that happened to be standing around the exit to the courtyard. And the question is, why might that be disadvantageous? So there's a couple of thoughts specific with this example that come to mind. If I'm interviewing students, not all kids eat in the courtyard. I know that as a teacher at a high school, I have a group of about 20 kids that usually hang out in my room every day at lunchtime. I would have missed those students if all I was doing was interviewing in the courtyard. In my school district, juniors and seniors have open campus, meaning they're allowed to leave for lunch. So I'm not going to catch all of the junior and senior students. It's going to be less likely that I catch a junior and senior because some of them are off campus. These are things that are problems as a researcher. It's going to create a sample that is not representative because I am missing subgroups of my population. Specifically, this is prone to bias. What type of bias depends on the structure of that convenience sampling. For my study with the high school students, I would be skewed towards freshmen and sophomores because there were more freshmen and sophomores on campus than there were juniors and seniors on campus during that lunch period. If you are doing polling at a mall, you're only missing people who go to the mall at that time, meaning they have free time at whatever time of day you're there. They have presumably money to spend. They are mobile adults because they can move around the mall freely. All of those things are things that I would need to consider when setting up my sample. If I'm using a convenient sample, I need to address those concerns when I'm describing my study. Okay, so enough deep discussions for one video. If you have any questions, feel free to email me or drop by office hours. Otherwise, I'll see you in the next video.